Welcome to Defn, episode number 52 with Gary Fredericks. Did I pronounce it right?
Sure, yeah.
Nice. So, this is Vijay from Holland.
Ray from Belgium. And Gary from somewhere.
I'm from Chicago.
Chicago, right.
Is it the Windy City?
Yeah, I guess so. Yeah.
Is it windier than Holland? It can't be windier than Holland.
I've never been to Holland.
Okay, then it is fucking windy here.
I don't know if it's particularly windy. It could mean something else.
Oh.
Didn't it used to be quite windy before all the development? So because it's in a certain part of the country.
I wasn't here then. It's a very flat part of the country.
Ray was there.
Geography,
Ray was there because it was all Panthea. It's like the one continent. The entire
yeah, exactly.
Earth, he was walking.
when I was strolling the earth,
What is it called again? Pangea or Panthea? Pangea, probably.
Pangea. Yeah. That's what we called it anyway back in
just
the
one
day.
Continent. So, what's happening? Oh, yeah, okay. Clojure. So, Gary, please, so how did you get into Clojure? Maybe give us a bit of introduction about yourself and then, tell us what you're doing these days and how did you end up here?
Here, like on the podcast, you mean?
Yeah. Everything, culminated to this
roads
moment.
lead to Rome. All Clojure code leads to Defn.
Yeah, okay. Right. So I guess it was maybe 10 years ago. I was first starting off in software development, and by coincidence, I ended up working for a guy who was interested in new languages. And he just told me to go learn Clojure and Ruby and Scala and Erlang. So I was just learning like all of those within the space of 6 months and not using most of them for anything serious. But
what kind of gig was that, by the way? Because I've never heard of that kind of approach to literally anything.
Well, I mean, I was working for government, so it didn't really. It didn't like nobody else there was doing that, but like the particular guy that was telling me what to do, he was interested in languages. And we ended up writing some code that got rewritten later in a more standard language. So it wasn't stuff that lasted there for very long. But that was how I got into it. And I guess I don't really remember like my impression of those languages at the time, but somehow Clojure ended up being the thing that stuck more than anything else. So I've been using it professionally since then. Sometimes more, sometimes less. There's usually like a lot of Ruby code nearby. So I'm familiar with that too. But I spent a lot of time on like IRC in the earlier days. And so I learned quite a lot of Clojure just by watching and participating in those conversations. And I had time for doing random open source stuff at that point as well. So I've made a few libraries that have ended up being, moderately useful to some people. None of them are like extremely popular. I've made plenty that like nobody ever used because they were terrible. And a few things that are just jokes mostly. So
you belong on the show.
I had 3 or 4 jobs in a row that were all Clojure and writing generic kind of business code generally, whatever fit the context of the company or organization I was working for. I guess I started doing more like speaking and maybe 5 years ago. Like I tried out speaking at conferences and I enjoyed that a lot. I also took over the test check library. I don't remember if it was a contrib library at the time. I think it already was. And Reed was interested in working on other things, and I had already worked with him on it because I was using it at work and wanted to add features. So I'd gotten really familiar with it, and it was the of all the Clojure ecosystem libraries, it was probably the one that was closest to the sort of thing that I enjoy working on, because just all of the algebraic or algebraic's a good word, aspects to how you build generators and that sort of thing. And it's written in a really pure functional style, in a way that
maybe you can give us a quick intro about the library for the people who don't know.
Sure.
Yeah.
So ignoring history, test checks a contrib library for doing what's called property-based testing, and that's usually contrasted with example-based testing, which is I think a term mostly used by people advocating property-based testing as a way to summarize all of the other kind of automated tests people do. And they say example-based testing because they want to emphasize that you're writing a test that just tests one particular example of how your program might run. Whatever test data you're using, it's just one thing that might happen, and you often have to explicitly think about what edge cases might be interesting to your program, and depending on what kind of programmer you are, you may or may not even bother testing edge cases. You might just write happy path tests. But regardless, the onus is on you to kind of list all of the edge cases that you want to test and actually think through those things. And so property-based testing is about describing more abstractly what your program should do without giving specific examples. Something that should be true regardless of what data or inputs are used. And then if you can sufficiently describe the data and inputs, then test check can just generate as many examples as you have time for and test all of them.
Yep.
So there's a lot of trade-offs there, and in the best case, it's something that will find all of the edge cases for you and find bugs you weren't even thinking about. It has a feature called shrinking, where if it finds some data that fails a test, then it will ideally simplify it to the most basic example of something that fails in a way that will hopefully make it obvious to you what the bug is, so you can go fix it. I could go in a variety of directions from there. So I want to see what are you interested in, I guess.
So I think usually one of the only questions that we ask our guests is Emacs or some other shit.
Random direction there, dude. But okay.
Emacs.
He said any directions. There is only one way.
8 years ago or so, I was using Vim and a standard QWERTY keyboard layout, and my hands were hurting from typing too much, and so I just decided to try two things at once, which was I switched to Emacs, which sounds odd at first because Emacs,
especially if your fingers are
Emacs, you just have to hit control and all the mod keys all the time, so it sounds like it wouldn't help. The rationale was that you don't have to use Emacs that way, and Emacs is so configurable that if you find yourself typing a whole lot, then you can write elist code and figure out how to not type as much, even if you are reaching for modifier keys. I'm sure in theory Vim is configurable as well, but in practice people don't like to do it. So I switched to Emacs. I also switched to the Dvorak keyboard layout, and largely my hands have not been hurting since then. So it could be that either of those two things helped, or by coincidence something else helped. I just have no idea. It wasn't very scientific, but now I use Emacs and a funny keyboard layout. And I do a lot of weird things with Emacs, and Like I think the thing that would make it hardest to quit, at least especially for personal stuff, is org mode. Like I didn't know about org mode when I switched, but it's exceptionally useful in all sorts of ways, and I use it for my entire life basically, and I use it quite a lot at work as well.
Is it like Jira?
That's one of the kinds of things you can do with it. I guess I use it in that way, and lots of other stuff as well.
I think you got the direction of relationship wrong, Ray. I mean, it's not like Jira. Jira is like everything is like org mode, so it's,
right, yeah.
The direction points that way. It's not the other way around.
Yeah, Jira does a few of the things that org mode can do.
Exactly, and everything is like Emacs or something.
Yeah.
Anyway, so awesome. I think that's the exact answer that we wanted to hear. Now we can go into all sorts of directions. So coming back to the test check. So before coming to Clojure, as you said, you were, or maybe writing Clojure code, you said there were plenty of other languages that somebody suggested to you to learn. Usually, if you see generative testing, I think that's coming from really statically typed languages.
Yeah.
Like Haskell. So how do you contrast that with Clojure generative testing versus, for example, something like Haskell or Scala where there are types and everything?
Well, one of the differences is I think it grew up in the statically typed language ecosystem partly because when the computer knows your types already, it can create rudimentary generators for you.
Yeah.
So that saves some work, and that's the exact same strategy as with spec, where you're using spec, and so you've already described the shape of your data, and so ideally spec can create the corresponding generators for you. I certainly haven't done generative testing in statically typed or property-based testing in a statically typed language, so I can't talk too intelligently about it. My sense is, well, I was going to say something about how, I know when you use spec with test check, once things are complex enough, you find yourself needing to write your own generators anyhow to describe things that are probably either not captured by the native specs, or you've written some predicates to test consistency in some larger data structure, but spec can't just use your predicate to write a generator, and so you need to do something custom in order to generate stuff that matches the predicate. My guess was that sort of thing would apply in Haskell, et cetera, as well. That you can generate things from your types, but there'll inevitably be some more complex things, so you'll be forced to write some of your generators. But that might not be true. It might be that if you were really diligent about correct by construction kind of approaches, that you would end up with just all the generators just work because it's impossible to generate something that's invalid. I have no idea how feasible that is in real life, but it sounds nice in theory at least.
Well, my guess is that with certain typed languages, the number of options that are possible are kind of explode a little bit as well.
What do you, by options, you mean kinds of things you might want to generate?
Yeah, well, if you've just got a spec, then to some, how do you choose which path of when you've got a compiled language, you still have to follow a certain path, don't you, to get to a particular type. And if you're using generics or something like that, then in theory there are lots and lots of implementations of this thing.
Yes, but if you're using generics, you ideally, I think you're in a situation where you can prove that it doesn't make a difference what the parameterized type is. For example, if you're testing a list reversal function, say, and you're in Java, and the type is a list of some type parameter, a list of foos. Not foos. Something abstract where it could be any concrete thing when you actually call it.
Yeah.
The compiler shouldn't let you do anything that depends on what kind of type is being used, unless you've specified that it has to be something that implements this interface or something of that sort. But like for a list reversal function, you don't need to know anything about the objects that are in the list, and so that should be evident by the type. And then if your generator system is sophisticated enough that it can tell that it's impossible for you to do anything that depends on what kind of objects are in the list, then it maybe it doesn't need to spend any effort generating weird things to put in the list. It could just, generate a bunch of numbers or something like that and be satisfied with that.
That makes sense, yeah. So it could actually optimize it a little bit ahead of time.
Yeah, whereas with Clojure, you don't have those kind of static guarantees, and ultimately you can pass anything to any function, and so there's a lot more of, especially when you use spec. I don't know if spec does this, but yeah, spec has this aspect where you describe maps that are open, and then you can have arbitrary extra keys.
Mm-hmm.
And one approach to generating those things could be that the generator just adds lots of random garbage to every map, just in case it happens to be something that your code looks at by accident. Yeah. And I don't think it does that, because that would slow everything down, and it would it'd be lots of garbage on the screen that you'd have to sift through every once in a while. So it's just one of the trade-offs it makes. But in Clojure, that would be a valid way of testing. Is you can always just add random stuff everywhere.
Yeah. Mm-hmm. So this is also obviously useful on Clojure script as well, right? Both Clojure and Clojure script.
Yeah.
The
there's a caveat to that, at least currently, which is that I don't think that we have anything wired up for doing asynchronous testing in Clojure script. So it's mostly just useful for testing business logic, pure functions, that sort of thing. I haven't done a lot of that, but I made sure that it the library at least compiles in Clojure script and all the test paths and that sort of thing.
Yeah.
So what's the async story then?
You mean what would you do if you wanted to test async code with test check?
Yeah, in general, yeah.
There might be a variant, a fork somewhere that does it. There's probably a branch in the test check repo, maybe. I'd have to look into it. It partially depends on what the test runners currently do with async code. I think Clojure test is set up to do async in Clojure script, but I don't know that for sure.
No, I just mean in Clojure.
I haven't tried this. Oh, in Clojure?
Yeah.
If you're on the JVM, then you can always take any kind of asynchronous code and just wrap it in threads that wait for something to be done. So it's not really an issue. It's an issue in Clojure script because the JavaScript runtime won't let you just block, run one thread that waits for another thread and then does something afterwards.
Well, the general issue with asynchrony is just the ordering of things. So is that something which test check kind of manages as well?
Oh, no. That's something that Reed really wanted to do, because he was the model that he built test check on was an Erlang implementation.
Right.
Yeah.
It might be called Erlang Quick Check. I'm not sure.
Yeah, I think Quick Check, yeah.
But I think it or some associated library has a feature where it will manage all of the background asynchronous message passing stuff, so that it could test things happening in different orders and isolate race conditions. And so Reed wanted to do that with Clojure. I don't know if he wrote any code for that. That would be a lot of work, because you'd have to get into the guts of at least Clojure's multi-threading stuff. I assume all atoms and agents and futures and all of those things, you would want to be able to orchestrate what's going on, and that might be possible technically. You might, ideally you'd be inside of the JVM manipulating all the JVM level concurrency mechanisms, and that's, I'm sure, a lot harder and maybe not possible most of the time. And so you'd be doing this compromise where it only applies to people that are using the Clojure level concurrency thing. So I don't know if it would end up working very well. But that's the story as far as testing for race conditions. And in practice, when I have code like that I'm trying to test check, what I'll do is wrap it in synchronous code like I described earlier, and so now you have a test that could fail randomly. It's not deterministic, which is not ideal for a test check. But if it fails often enough that you could say wrap it in code that will just run the test 10 times and only pass if it passes all 10 times, you can get some leverage out of that. That'll of course slow your test down even further. If it doesn't fail that often, then you're in a situation where it will, if it ever fails, it will at least tell you that here's an example where your test can possibly fail. And so now what you can do is take that example and just run your test on that example 10,000 times and just measure how often does it fail. Hopefully it fails often enough that I can tell whether it's failing or passing at least within an hour or a day or something like that. It's not fun, but if you have a race condition that you care about, then you'll be able to invest the time to track it down by that mechanism. And so test check is something that will at least find bugs like that, even if it's difficult to really debug it and fix it.
But that really depends on the amount of iterations that you run, right? Because the generative testing always seem to be, at least to me, it's not an exact testing, but we're going to try with the computational power and the time, depending on how long it's going to take, then hopefully it is going to find.
It's like SETI, isn't it?
Is that a correct assumption? Yeah.
What did you say, Ray?
I said it's like SETI. Yeah.
Oh, the alien thing.
Yeah.
Yeah.
Yes. Yeah. It's the kind of if you really wanted to, and I'm sure some people do, you could have a machine that's just full-time dedicated to running your property-based tests 24 hours a day. There was just one thing I worked on where that was useful. It was open source actually, a library that's about test check called Test Chuck. And the most interesting thing in it is a generator of strings that match regular expressions. So you give it a regular expression, it gives you a generator of matching strings, which means that the work it has to do is to parse and understand the regular expression. And understanding a regular expression means, on the JVM, means that you have to understand all the details of JVM's regular expression class, which is very complicated. And so in writing this code, I also used test check to test that code to make sure that I was understanding the regular expression correctly. The first thing you have to do is, given a string, a string version of a regular expression, decide whether it's even valid. Can I parse this correctly? And you have a built-in reference implementation of that in the JVM. You can also, in Clojure, I think it's called re-pattern.
Yeah.
The function, you give it a string and it'll return a regular expression, or it'll throw an exception if it's not a valid regular expression. So I could test my parsing code like this. I could generate a random string that may or may not be a valid regular expression, check if my parser thinks it's a valid regular expression, and check if the re-pattern function thinks it's a valid regular expression, then I just assert that those two things should match. They should either both succeed or both throw exceptions. And so that was a really good test of my parser, and that was something where I could run it for 24 hours and once I had gotten out the easy bugs, it would take 24 hours to find the next bug.
It's like Bitcoins.
yeah. It's all
mining bugs.
So
bug
it's
mining.
like a cryptocurrency for bugs. Yeah.
Yes.
That's what you should really put. You should put people do these Easter eggs for JavaScript where they embed like a Bitcoin mining code.
Right.
That's what
Easter egg,
that's what
quote unquote.
That's what you should do for test check.
Yeah. You've got a website and all of your users are secretly running your test.
Exactly. And then when you get caught, you're like, that was an Easter egg.
Or just mining Bitcoins on your behalf, It's like
Yeah. If I ever succeeded in mining a Bitcoin, I'd send it to you, obviously.
Good to know.
And how does the other side of the thing work? Because this is also something that is very fascinating to me. What do you call it? The narrowing the
shrinking?
examples,
The
right?
shrinking.
Yeah, shrinking. Sorry. Yeah. So how does that work? Because I don't want to make any stupid explanations because I don't know how does it work.
Yeah. This is the biggest difference between test check and the original Haskell quick check. I think Reed may have guessed how it worked in the Erlang version and used that, or it could have been completely original. I'm not even sure. I think a lot of more modern quick check variants do something similar. But anyhow, in the original Haskell, you would have to like supply a shrinking function. Like if you made a generator, you would need to give a function that like takes some example data and then returns a list of smaller pieces of data. And so that's a lot of work, and you have to think creatively about it. And I mean, you can probably just decide not to do it, and then you don't get as much of the feature. But anyhow, in test check, the shrinking is intended to be just automatic. Like all the built-in generators have shrinking functionality built in, that go with them. And when you write your own generators, you're doing it using the provided combinators in test check. So like there's the fmap combinator that says, if I want to be able to generate, I want to generate this thing and then transform it using a function. And the fmap itself has built-in shrinking. So if you write a custom generator that way, then you're still going to get shrinking for free because it can shrink the original thing and then pass the shrunken version of that thing to your function and get a smaller version of the output for that function. That's true for all of the combinators. So the intention is that you should never have to think explicitly about shrinking. It should just work. In practice, it's useful to know something about how it works so that you can optimize things so that it shrinks faster. I think that's usually the only issue is that shrinking can take a long time if you're generating very big things, or like if you're generating big things and your test is really slow. Like this would happen to me where I was running these really sophisticated tests that would have to generate like a megabyte of data, and then the test itself would take several seconds for each instance. So it would run for a while, maybe like run for, if you want to test 100 trials, then it'll take a few minutes. But if it found a failure and now it has this several megabyte data structure and wants to shrink it, that could take a day in the worst case. And so, when you're in that situation, it matters, whether you have options for optimizing shrinking. I don't think I told you how it worked, really, did I?
No.
Well, you give us the outline of it. That's good. Yeah.
The only there's like only one generator that has like really original shrinking algorithm built in, and that's the like positive integer generator. That was probably a false thing I just said, but I don't know how it's false, so I'm gonna stick by it for now. There's this generator, really fundamental generator that just generates a number up to like I guess I should back up. There's when you're running tests, there's something called a size parameter. This is because it wants to start with small instances of data, and so that you can fail quickly. If it doesn't even work for the small things, then it'll fail right away, and it'll be small, and it won't have to shrink very much. So it starts out small and then tests on larger and larger things. And the way this actually works is that it just has this parameter that starts at 0 and goes up to 199. If you run 200 tests, it'll go all the way up to 199 one by one. And then if you run more tests than that, it goes back to 0 and just cycles around. That's how it works by default. And so there's this integer generator that just generates a number like uniformly from 0 up to the current size. So it'll generate small numbers at first, and once you get up to like 199, it's generating integers all the way up to 199, which isn't very big. But regardless, there's the way that shrinks is, I might even not be able to describe it accurately. It'll I probably like try 0 first. Like if it can shrink the number to 0, and the test still fails, then it saves a lot of effort. If that doesn't work, it'll probably try dividing it by 2, so that in the best case, if you have a test where it like fails above some amount, then it should get there quickly. Like in using a binary search. And I think that's what it ends up being, is something like a binary search. So divide by 2, and if that doesn't work, then try halfway in between those. It might end up being something, slightly different algorithm, but it's, certainly smells like binary search. But so then you have a lot of the built-in generators are created using the combinators that are available to users. There's like collection generators. So a collection, I guess, also shrinks kind of in a custom way. So if you generate, say, a vector of things, if it's not intended to be a particular size, then it can shrink in a couple ways. It could shrink the individual items in the vector, or it could shrink by just removing items and giving you a shorter vector. And so it interleaves those strategies. It might try with an empty vector first, and then try cutting the vector in half. And if it can't remove things at all, then it'll just start shrinking individual elements. It's amazing how much I don't know about this, even though I've worked so much with code.
I think you're doing well.
So fmap I described earlier, like it's just a pure function that you're mapping the generated value, and so it can shrink the prior value, both the input to the function, and then call your function again.
Yeah.
There's generators like tuple, where you want to you supply several generators, and you want to generate a vector that has an element that's one element from each generator. And so that shrinks by just individually shrinking the generated items. It can't shrink by removing them because it's static length. Each of the combinators or built-in things sort of has its own natural way of shrinking.
And this can be fairly complex operation for arbitrarily deep structured or data structures in Clojure, right? If there is a vector of a map of vector or something like that, then especially because it's not only at the top level form, it needs to shrink the individual vectors inside a map, value. Yeah, something like that.
Yeah, it's sort of defined recursively. So if you have some sort of deep structure like that, like you can look at what's the top level thing, what's the collection, and so we'll try removing elements at the top level, and we'll try shrinking elements at the top level. And then so if you're shrinking one of the elements, and that element's a map with a whole bunch of stuff in it, then you have to think about how to map shrink, that sort of thing. There's another generator called such that will filter generated items on a predicate, for example. So you give it a generator and then some predicate, and it'll give you a new generator that only generates things from the other generator that match the predicate. And so that has a natural shrinking definition too, which is you shrink the original thing, but only try things if they match the predicate. In a lot of cases, I think you can kind of figure out like what's the natural thing to do here without having to actually look at the code.
Yeah. And how does because we have spec now and then in alpha, but we had spec for a couple of years now. And so how does that help in terms of this one? Because obviously some of the generator guessing can happen by just reading the specs and then using specs as the input, right?
Yeah, that's certainly the intention. I don't think I've used this. I don't think I've used spec with test check myself very much. Certainly never at work. And I understand how they're wired together. My sense is that if you're using it for serious stuff, then you're going to have to be familiar with how test check works. Like you can't just rely on spec to run your tests, because once you have complex enough stuff, you need to write custom generators. There's a few different gotchas in how they're connected, and I mean the test check in general has a variety of little things that are kind of difficult to use about it, I would say, and which is something I've thought about a lot, and tried to make it easier to use when it's obvious how to. But that's like one of the most difficult things for me in maintaining it was, watching people use it and seeing what's difficult and trying to think about something that would make it easier without ruining other things and making it more complicated to understand. And most of the time I just don't know what to do, because it's a weird kind of constraint to work under, where you're writing code for thousands of people that you never talk to and they never tell you they're using it, and you want to not break stuff when you change things. And I don't think I'm answering the question. You asked how test check and spec relate to each other.
It's okay. I mean, you don't need to answer the questions at all. It's perfectly reasonable to go in any direction you like.
Yeah, I mean, so it has a spec, for all of the different kinds of built-in specs that you can use. It will have a definition for how to generate something from that. So if you use the call of generator or spec to describe a collection of some other things that match some other spec, then it's going to use one of the generators for generating a collection. And so there's a lot of obvious pairing between the specs and the generators. There's a few weird edge cases, and then it also has code for instrumenting functions. And they made this choice that surprised a lot of people, where the default, I guess this doesn't have to do with test check. I was thinking about the way they only test the input, not the output in instrumentation. And that's not actually about generators. I guess test check, that's a different entry point, where you give it a function and say, test this thing. And it will generate the inputs and call your function, and then I'm going to make sure it doesn't throw an exception, and then also test the type of the outputs need to match the spec. And I think, and with spec you can also test, add a I forget what they call it, but it's a validation function that will take the input and the output and assert something about them. And I assume that's also getting checked when you do the property-based testing. So it's not only writes the generators, in effect it writes the tests for you. And one of the difficult to use aspects is that the entry point for running those tests isn't wired up to any of the normal Clojure test stuff, and so you have to, at least last time I looked, you had to write some a minor amount of custom code to make in your test you run this other thing, and you make an assertion about it, and I don't know where you see shrunken values when your tests fail and that sort of thing. One of the difficulties in working on testing libraries is that there's this whole ecosystem of testing tools, and they all need to know about each other, sort of. If you want it to be really ergonomic, then like I talked to Colin about what's this thing in IntelliJ? Cursive. Like, and he wanted to be able to like show little things about what values were getting generated in the test check test. And so I had to think about like what does test check need to expose to make that possible. And then there's like other ways people run their tests, and there's like there's test runners and there's IDEs and there's, when it's just this like flat ecosystem of lots of different tools playing lots of different roles, all trying to interoperate, I think it gets really difficult to make it a good user experience.
Yeah. So what is the future for test check? What are the things that are planned, or what do you want to focus on, or what do you want people to contribute to?
Right. So let's see. I described some of the difficulties in maintaining it. One of the things I did after I took over was I filled in a lot of generators that felt like they were missing to me, things that I would need frequently. And I did this whenever I thought it was obvious what a good implementation would be. Like I added like generators for larger integers and for collections that have distinct elements, which was a hard thing to do in userland, and UUIDs and a bunch of other random things. And that was all in the 0.90 release, which was I think 3 years ago now.
Yeah.
And then I started working on like all of the stuff that was not easy enough to do in that release. And so I was just like, I had all these hard things. And so, I mean, between that and not wanting to devote too much time to it, all those features have sort of dragged out, and I made some alpha releases a few times along the way. But it was only in the last month or so that I decided I wanted to finally like try to put together a proper release out of those 3 years worth of sort of hodgepodge efforts. Partly because there's one or two things that are fairly useful to spec, and spec can't be changed to use those things until it's really released. So there's like this release dependency there, and there's also like things that would just make the user experience better. So I really wanted to get that released, and that requires like abandoning some of the things I wanted to do that are just too hard. But last month I got it in what I think is a good enough state to release. So I made an RC release, and have no other things I'm planning on changing. So I'm just letting that bake. One person told me he was using it, and I haven't heard anything bad from him or anybody else. So I assume nothing else will come up, and then in a few weeks I'll cut an actual release.
Yep.
After that, I think I'll probably be more passive, because at this point there's only the really really hard stuff left.
You've got to go to your hammock at this point.
I talked to Stu Holloway about this a little bit, and one of his comments was that the best thing you can do is just leave it the way it is. Like, it works, and like adding a bunch of features might end up breaking stuff. He's really focused on stability, and you can see that in the language as well. So, in a sense, people haven't been clamoring to have stuff done. There's just all these like vague things that are not ideal about it, but don't have obvious solutions. So anyhow, I don't think I'm going to be like actively working on another release after that. So I'm happy to talk to anybody that wants to work on that. And I have a long list of things I wanted to do, like problems I saw and ideas I had. Like, I've really wanted to like reboot some of the namespaces, like the generator's namespace, or the quick check namespace or the def spec stuff. Yeah, there's one of the most difficult things about making it easier to use is you need to also, like, the stuff that was hard to use needs to stay there and still work and be documented and that sort of thing. And so it's this constant problem of how do I have both of these things, and eventually you just end up making it more confusing because you've got all these versions of things that people have to understand and choose between.
Yeah.
I have a long list of like fantasy ideas that I largely didn't do, but they're still there, and I think I still understand them and can explain them. That sort of thing.
Yeah, but I think it's a really, really great bedrock for this kind of testing, and like you say, a lot of things that maybe people want to do on top of it, they can do on top of it. They don't have, the library itself doesn't have to have the answer to all of these possibilities, does it?
Right. Yeah. I mean, there is a lot of stuff you can do in userland, and that was part of why I created the test chuck library. Was like I saw things that I could make more ergonomic by writing these helper functions, but it would be harder to decide to put them into test check. I created that library before I was maintaining test check, but even afterwards, I wasn't really tempted to just take all of the stuff in it and dump it into test check. Because there's a different standard for stuff you put there. It has to fit with everything else. It has to be something you believe is useful for everybody, or at least something that everybody should know about and have to decide whether or not to use. Whereas sticking it in a third-party library, there's a lot lower bar. So I think that's one way to solve the problem. But it's also not fun for newcomers to come in and be told, well, we use this library for this thing, and then there's this other library you should pull in that does, this other thing, and they probably work together well, but
it's the Clojure way, though. Come on.
Yeah, it is. But
break it and really they will come. Yeah.
I part of this I think is that I've always worked near people who have a lot of Rails experience, and they're used to this really cohesive thing where most anything you might want to do is something where you can Google and here's this one-liner, right, and you don't understand what it's doing, but you type it and it works and you're happy and you keep going. And the Clojure ecosystem is not that way. And so I that's the ideal that I want, because I want to make those people happy too. And it's probably just not possible.
I think it doesn't, just before we go on, there doesn't a lot of it, I was just going to say, doesn't a lot of this kind of stuff depend upon, essentially an opinionated perspective? Because I think, the main thing to me about Ruby on Rails is that DHH had a way of doing things. He had a strong opinion. He's a strong leader of that framework. And a lot of these tools, like Test Check, maybe I'm missing it, but it seems less opinionated. It's more of a toolkit rather than a directed solution to a particular kind of generic problem, like web applications.
Yeah, that's true in a way. It has its own kind of opinions, but
sure.
One of the things about Rails is it's not a programming language. It's restricted to a very particular kind of application. And when you use it for other random things, it starts getting more awkward. But when you're trying to build the thing that Rails was designed for, it's pretty easy to do. And Clojure was never. It's a generic language, so you're supposed to be able to use it for anything. And there is no community primary thing that we're all building. So all of these libraries are either built with whatever random thing the maintainer happens to be working on in mind, or else nothing in mind. They're supposed to work for everything. There's a lot less cohesion in terms of what application you're targeting and the style of thing you use.
That's why what I see from people, in the consulting world, like Matosin and Juxt and people like that, is that they tend to have like a preferred pack of libraries and then a preferred bit of glue code that they write. So I think that's the way people tend to do things, is that they don't have like one overarching framework, but I think Cognitech did Pedestal, didn't they? That was their original idea of a kind of replacement for Rails, but it's a lot of work to do the full stack, and I don't think it fits the culture very well, So as far as I know, it's mostly just like back-end stuff and, a better version of Ring basically with async functions. So, good stuff, but, it's very much a sort of slice of that particular domain rather than the whole thing.
Yeah, I haven't used it or like done the sort of things that would benefit from, and so I'm fairly distant from it. The vague like observer impression I got was that it perhaps could have been a lot more popular if they hadn't like gotten unlucky and designed and released it like right before React became a major thing.
Yeah.
So the whole like web development ecosystem kind of shifted out from under that. I mean, it was Ohm came out around the same time, I think.
Yeah. I think the front end story in Pedestal was fairly complicated.
Yeah, just unlucky timing. Like if they had done it a couple years later, and it would fit a lot better with those things, and maybe it would have been popular. I'm not sure.
Yeah. So there are two other things that I wanted to just ask you, like, what is going to happen with your library 71?
I think I have a. You made a pull request. I don't know if there is a my Gmail inbox is my to-do list, or is one subset of my to-do list. It's stuff that hasn't made it into org mode. And
there are 2 pull requests and 3 issues pending. So what do you have to say about it? Maybe first explain to people what 71 is, and then that's easier.
71 is a library that provides the number 71. In Clojure. I don't remember what if there's anything in particular.
Yeah.
I think I wanted to just make fun of libraries in general when I made it.
This is like the next level. I mean, LeftPad actually has some functionality in it. Yeah. This is the next level of shit. I think we should have one library for every natural number, and then people complain about there are not enough libraries in Clojure. Like we have infinite amount of libraries -1.
Yeah.
And then go on. And then 71 it is.
I might stress the Clojure or Maven ecosystem to try to deploy an infinite number of libraries.
I really want to use it, but the major version is still 0, so I'm a bit concerned about the stability of the library.
That's just the Clojure style, isn't it? You just all have.
That's true. Yeah.
The 0 dot doesn't contain any information.
Exactly. 0.1.5. Well, that seems to be okay.
Yeah, I'd be more in favor of just using at work we use integers, which I guess is easier since you're not trying to communicate to somebody what features are supported. But wasn't that one of Richicky's ideas in his talk about backwards compatibility? It was just use integers for versions. I haven't seen anybody doing that.
I think some people started doing it because I see this. Whenever I try to do pip install something, I get some weird number that doesn't make any sense to me anymore on Python ecosystem. So
you're saying Python people are doing it?
Yeah, like if you do, I don't know, pip install something, and then suddenly it will put in something in my, virtual environment. Like, okay, what does this number mean? I have no idea. But I think they are also catching up to the semantic thing a bit. But there are people who are using dates for releases, and I think it's a complicated thing.
If you're committed to the backwards compatibility thing, it feels like that could work. But I just haven't really been maintaining anything that's significant enough that I needed to do anything beyond just increment the number for the version. Yeah. So
that 71 seems like a solid library,
For me, I think
I think I might need to take a look at.
The problem I've got with it is that it just doesn't have deps.eden support. So I think it's.
It doesn't. I think that's one of the pull requests, right? Yeah, number 19. Or maybe it's just the issue.
No, it's just an issue.
Okay, yeah. Well,
yeah.
I mean, that's something we can improve. That's an easy one to.
Some loser opened that one. Oh, it was you.
One thing I haven't figured out is the whole library deploy or release lifecycle without Linigan.
With Defn.
Yeah.
No, you just put the last commit as the SHA, then you're all done basically. You still have to
upload it to. You got to make a jar and upload it.
No, you don't.
Jars.
No, you don't. No.
Oh.
If you make
I'm sorry. You're saying.
If you make a
deps.eden. GitHub.
Yeah. If your commit is a deploy, so you make a deps.eden file, and then I can depend on it, and we're all good.
Is that what a lot of people are doing? They're not even going to Clojures?
Exactly. Yeah.
I don't know, man. Then you're you need GitHub to be there.
That's cheating. I know. I think honestly they've got a bigger CDN than Clojures have. So.
Right. It's just a single point of failure thing. There's got to be other downsides to that. I haven't thought about it too much, but you can't. The Linigan people can't use it at all. Is at least a short-term downside.
I think let's get to some other less serious libraries than the final one. So can you maybe give a quick idea about what is CoinDB? Is it like competing with Redis?
Maybe it's MongoDB.
We only talk in terms of what is this MongoDB?
I think it's a kind of a trailblazer. I don't know that it has any competitors at the moment.
All right, okay.
It's too far ahead.
Yeah,
fair enough.
It's so advanced, nobody's using it as far as I know.
You need quantum computers.
Yeah, that's what the QU is supposed to mean. I think. Quantum.
That makes sense.
Right.
Now everything makes sense to me now.
Yeah. Go ahead.
Yeah. So maybe enlighten us a bit. What is CoinDB doing, and then
sure.
What can I use it for?
CoinDB is both a coin and a database. So coin meaning it's a program you can run and it just prints itself out. So it's a bash program in this case. So it prints a bunch of bash code.
Ooh.
And it's a database because the auxiliary functionality beyond printing its own source code is it's a key value store. And so it does both of those things by using the two different output streams on Unix. So the source code goes to standard out, I think, and then all of the database-based functionality goes to standard error. Yeah.
Awesome.
So if you run it with no arguments, it just prints its own source code. And then there's a few different commands that you can run. There's one for reading the value associated with the key. So you call CoinDB, and the first argument is get, and then the second argument is the key. And then it'll print its own source code, of course, to standard out. And then it'll also print the value that you stored under that key to standard error. And then you can also set the key to a value, and when you're doing writes, then it does something special, which is that it's not quite printing its own source code. It's printing a variant of its own source code that now has the data you wrote inside of it. So you have to, if you want to keep your data, you have to be careful to redirect standard out to somewhere useful. And you can't, I think a normal Unix bash situation, you can't just redirect it to the file that you're executing, because it'll truncate that file before it even tries to execute it or something of that sort. So you have to redirect it to a different file and then move it, or just keep both of them if that's what you want to do. But you're getting a copy of the database that has your modification in it, basically.
That is beautiful. Yeah. It's kind of a mini Datomic as well.
Datomic almost.
Yeah, it's a mini Datomic. You can keep as many versions as you want. It's great for backups and stuff like that.
It's like next version, Datomic.future.
Yeah, that's right.
Yeah.
Of course, there's quadratic slowdown as you add more and more keys.
Oh, that's the Q for
the what?
The QU is for quadratic.
Oh yeah, that's right.
Yeah, I think it probably makes it more secure as well. You know, it's less accessible to rainbow attacks. Yeah.
Right. Rainbow attacks are about passwords, and there's no passwords or any security involved here.
Oh, but that's where I want to store my passwords in the future. Come on.
Yeah. All right. Yeah. Perfect.
It's a key value store. Username, password. Well, what are you talking about?
But I don't understand why this is less susceptible to rainbow attacks. I think that would just depend on your password hashing implementation, right? It's independent.
Oh, I thought the running of it after you store a certain number of passwords.
Oh, making it slower, you mean?
Yeah.
Yes. So the fact that it would take a very long time to pull a password out of the database, would definitely make some kind of attack slower. Yes, that's true.
I mean, quadratically slower.
Yeah.
I mean,
that is the idea.
Is it really quadratic? Maybe it's just linear. Like the runtime is.
Okay, now I'm disappointed. Damn it.
Yeah.
I mean,
we need the big O's on this one. Come on.
Yeah, exactly.
There's something in the README about this. So I was able to insert 100 key value pairs into an empty database in a mere 10 seconds. And the runtime of each operation is probably in login.
I think they should be one of the themes of software development, right? I remember when I was, I think in Italy or something, there is something called slow food movement.
Yeah.
Yeah.
So, like all these Rust people saying, oh, my shit is so fast and all that. And then we go to the other side, like slow software.
Yeah.
That is our thing.
Yeah,
like over the time, it goes slower and slower and slower. So you can relax and then, you know, have a tea or whatever and then insert into something. And then you just go and have a cup of tea. And then by the time you're back, the insert is finished.
It encourages people to slow down and do other things.
Be more mindful.
Yeah, chill out.
Yeah.
Mañana.
Okay. Yeah.
Yeah, I think that's right.
We'll have your password for you, mañana.
I think this is going to be fucking amazing if we have test check testing QuineDB that is getting slower and slower for every, and then that could be awesome.
Yeah.
Shrinking is going to be really, really useful there.
Arbitrarily slow.
Yeah. I did notice that you had test check on 71, so that's pretty impressive.
Oh, yeah. And I might have used it for QuineDB to make sure it worked. I have some unit tests in Ruby just because I wanted to write them really fast, and that was the fastest thing I could think of that needed to run a bunch of shell programs or shell out to a bunch of stuff. But maybe I didn't use test check. I don't know, but
yeah, I know.
Go ahead.
One of the things I off topic really a little bit. One of the things I noticed was that you say the QuineDB requires Bash 4, and I just happened to notice today that the Mac uses Bash version 3.
Yeah, good to Z shell.
And I know, and you know why that is?
I do not.
It's because the Bash
BSD license.
Bash version 4 went to GPL v3.
Yeah.
Oh, no.
Yeah.
So, Apple
might never have
no fucking way. We're not having that.
Wow.
So you can install it via Brew. So I think you should definitely be friendly to the macOS guys and help them out with a Brew install there. But
provide the command.
In the next version, Mac OS will switch to Z shell, right? Or Z shell, whatever you want to call it. In the next version, they're going to switch to Z shell as the default one.
That would be I think that would be nice, but
so maybe you need to port it to. Yeah, it's already announced. So they're gonna make Z shell as the default shell.
Right.
In Catalina or something. Okay. The next version.
That might be. I've resisted using alternate shells because I feel like I don't like having to know several kinds of fundamental tools. I don't want to use more than one kind of text editor, and I don't want to use more than one kind of shell. And I feel like you always have to know Bash.
Yeah.
But if Apple is switching to Z Shell, maybe it'll become more ubiquitous.
Yeah, but it's a bullshit reason, though. It's just because of this licensing crap, you know.
Yeah. No, I mean, no matter what the reason is, though, it might. I don't know if is it available in modern Linux operating systems, or do you have to install it?
Z Shell. Oh, totally. Yeah.
You just type ZSH, right?
Or Z Shell.
Yeah.
ZSH.
Yeah. Not Z.
Nope.
Come on.
Command ZSH not found, but can be installed with sudo apt install ZSH.
Yeah, ZSH.
Yeah.
Okay,
so
it's not there.
Not there. Maybe some.
Well, I think Debian 2027 will probably catch up and then have this one in the stable.
Well, what we're talking about now is like the year of the Z Shell desktop. Yeah.
That's right. Yeah, year of Z Shell on the desktop. And there's also Windows is trying to get all the Linux developers.
Yeah.
So that's another factor.
Yeah.
You have to get them to switch to I don't know. I assume they have Bash. I don't know what else they'd be doing.
Yeah.
But complicated.
Anyway, but what are the other languages that you're looking at? What is on your radar now, apart from Clojure?
I used to care a lot about languages. Like I was advocating Clojure a lot, maybe 6 or 7 years ago. But I'm like, my personality is just really wishy-washy, and I don't like to commit to anything. And so as soon as I saw anybody having trouble with Clojure, I just sort of backed down and like, I don't know what anybody should do ever. Lately I've been more like professionally, I've been more interested in like working on just whatever the like business people think is important, and trying not to have like strong opinions about languages unless that really is the core of.
So you're going to be a COBOL developer.
Yeah, that's probably what's going to happen.
You're going to be a SAP developer, aren't you?
A staff developer, is that what you said?
No, SAP.
SAP. Oh, SAP.
Yeah.
I don't remember what that is. It's an old thing.
Well, it's like an olden days version of Salesforce, you know.
It's from what?
Like
you said an older version of Salesforce?
An old school type of thing that Salesforce is now. You know, it's like an accounting, resource management software.
Everything.
Yeah.
Salesforce has its own language.
Yeah, a lot of factories and kind of like small businesses run on SAP. Yeah.
Yeah.
Small. Yeah. The entire Germany.
Them as well. Yeah.
Yeah.
BMW runs on SAP. Yeah.
Okay. It's just a language, or is it like a whole?
No,
like
it's
like a whole.
Yeah, it's like a whole ecosystem.
So it's like a huge amount of software, including a database and all other nonsense that comes with it, and then it has different modules to manage your HR, payroll, logistics, insurance, this and that, invoicing. Practically the ERP system, enterprise resource planning.
It's basically business software.
But let's not talk about it. You know, it's not as complicated as 71, but still.
Yeah. I'm just saying, if you are really gonna like care about what the business think, then you're gonna have to become a SAP programmer or something similar. You know.
Yeah.
ABAP. Yeah. The ABAP. They're all ABAP. They're all apping things.
Anyway.
Yeah.
Yeah.
So what do your business care about, Gary?
Yeah, so that's what'd you say?
What does your business care about? What kind of things do they care about?
Well, they want to make money.
Yeah, okay, shocker. Yeah.
There's a lot of I work at a trading firm called DRW, and there's a lot of variety of people doing different things, different languages. I think there's a lot of people that like Java in different ways. Anybody close to like data science kind of applications, probably using some kind of Python, something similar. There's certainly people that use C++ because it's fast. I haven't done that yet. I think that would be fun. At least
you're
if
wrong
it's like
about
being done
that,
for good reason.
okay.
It's not fun.
It's Rust.
Fun in a sadistic sort of way.
It's definitely not fun. I mean, get your kicks, I suppose.
I like knowing how things work, and so like using a lower level language will force you to, at least know more about things like processor details and that sort of thing.
I think you'll definitely know how things don't work. Yeah.
Yeah.
But I think C is still quite nice. If you,
do you think there is a particular subset of C++ that is nicer than C?
Rust.
Yeah,
that's what people keep shouting on the internet.
I think Rust is a nicer version of C. It's got more exceptions, and it's more
static.
It's got typing. That's the main thing. Yeah. Whereas with C, you don't have that, which is can be very nice. That makes things very flexible. But
if you use C in a particular way, will you get enough static type checking, or can you not even opt into that?
No, there's nothing. It's got nothing. Yeah. Well, it's got things like integer, and it's got enum, and union,
and a pointer somewhere.
And struct.
That's it.
Right, you can make a bunch of structs and get type checking on that.
No, not really.
No. Really?
Yeah.
No, because usually you don't pass the struct by value, right? You just give a pointer once you have a pointer.
Yeah. You just start filling it. Yeah.
So it's just a bunch of bytes and then pointing to somewhere, and it could be anything. So
yeah.
That's the fun stuff.
You think Clojure's loosely typed? Forget it. You're just pointing to some memory addresses that loosely might follow some bullshit that you say.
But okay, so if you have a function that takes a pointer to some struct, and at the call site, it's what you have is declared to be a pointer to something else. Won't that be a compile error?
Yeah, there'll be a compiler error.
Like I know you can write code that will get around it. The same way you can like typecast in Java. But what I want to believe is that if you are disciplined and avoid doing the trapdoor stuff, then you'll get static type checking. Like
for level 1, yeah. For the very, very surface level, yeah. But it's almost impossible to stay at that level in C.
I know a lot of the more OS-oriented libraries and functions are really insane to work with. You have to check Erno everywhere.
Oh yeah, but that's Go. I think is like that,
Yeah,
but the main thing,
there's something worse about it too. I think where you have to save its value before you do anything in case it gets overwritten and then restore it, or I don't know. It sounds like a lot of fun.
But that's what if it is making money for business, why not?
Yeah.
Yeah. I mean, it might take you 15 years to write the thing that you're making money for, but keep the faith.
Hey, Linus made Git in I don't know what, a weekend or something. Is that what we say now?
That's what you just said. So I'll buy it.
Yeah, exactly. Yeah. So he made it in just 1 weekend, and I see a lot of noise on Twitter these days, like 10x programmer or something. So if you're a 10x programmer, then it's like in 2 days you can create Git.
You can do anything in C in 2 days.
Yeah. I think so.
You're probably right.
Anyway,
well, another direction for the language question is something I would be interested in seeing would be statically typed Clojure-esque language. The main difference from other statically typed functional languages would be more of an emphasis on generic data. I think that's one of the more interesting things about Clojure. But I've never gravitated toward dynamically typed languages in general. I like having a computer tell me that something's possible or impossible. I could believe that maybe you just can't fit your program into that paradigm and it's always going to be costly or something like that. But, I still want to try. And so one thing I think about a whole lot is a language or a VM that's based around JSON. So it has a totally closed set of possible types. You can only have a map or a list or strings or numbers or booleans, and that's it. You just have to assemble everything from that. And then like, you could have static types around that, and just lots of other ideas that probably don't actually work if you try them. But something like a little bit like JQ, but like a full-fledged programming language.
Yeah. But is this the main thing that is kind of pulling you away from Clojure, or getting?
No, that's just a random
interested?
fantasy.
Yeah.
Using Clojure less is just that there's a lot of people doing other things with other languages, and I'm just more interested in what the work is accomplishing than I am in what language is being used.
Yeah. Cool.
But what would be what are the main features in Clojure that you would say that that were very valuable so far? Of course, given the lack of static typing, obviously that is one thing that that's probably other languages, different paradigms have. But what would be the pros of Clojure, or in your experience so far?
Just the general question of what I think is good about Clojure.
Yeah.
I think there's this. I think of Clojure as being the combination of this pure functional core, and then a lot of really messy stuff for gluing it together and interoperating and doing things. And so I think there's a lot of value in trying to write pure functional code for your business logic as much as you can.
Yeah.
Especially for things like debugging. Like being able, if you find out, this happened to me a week ago, you find out something in production is not doing what somebody expects, and you somehow get, via logging or something like that, you print out the argument to the largest pure section of the code that's not behaving as expected. And then you can just paste that into a REPL and run it on your version of the code, and hopefully reproduce the bug and just iterate on that. And so I think that's fairly useful. That part would presumably apply to a statically typed functional language as well. So I don't know. Like I said, I'm a really wishy-washy person, so you're going to have a hard time getting me to really sell something.
No, you don't need to.
It's certainly I know the tooling very well, and so I can be very productive in it because I know how things work and how to move around and accomplish stuff, and that's definitely not true for everybody. I think the generic data stuff is interesting to contrast with the more nominally typed functional programming you see in Haskell, etc., where people they model things by creating a new type. So you've created a new kind of thing, and it's something that can really only exist in your program. And if somebody created a type in another program that happened to have the exact same name, it means something different, probably. And so your modeling only is only talking about about things inside your program. And I think Clojure has this approach where it's attempting to give you modeling tools and other tools that apply outside a program as well, can be used in an open ecosystem of software. I have this analogy with Erlang, where Erlang is to a large extent about concurrency, and I feel like the rationale there is that you're going to have to run your program on multiple machines and have a distributed program at some point anyhow, if your program is important enough. So why don't we just bite the bullet and write all of the code from the beginning as if it's a distributed program? And if it happens to be all in one machine, then that's cool, but it doesn't need to be. And so I feel like Clojure does that kind of thing, but not about concurrency necessarily. I mean, a lot of like Clojure's concurrency stuff only works on one machine. But it's about the data modeling and the fact that like the data is immutable because once you're passing data in between programs, it's effectively immutable anyhow. Like I can't call some web service and get a JSON response and then locally manipulate that response and expect that that has any effect on what's happening in the server. Like it's immutable in that sense, and I should treat it immutably. And so I feel like Clojure has this same sort of bite the bullet strategy of saying like you have to pass immutable data around once you grow outside of a single process anyhow. So let's do that inside the program as well. So ideally that, leads you to programs that you can more easily split out because they're structured in such a way that you're just passing immutable data from one part to another, then you can do that from one machine to another and it behaves the same way. So that's that to me feels like something you can't do in the statically typed functional programming paradigm. Not because of static types in particular, but because of like the nominal typing approach of make a new kind of thing to describe your data. So that's why I think it would be really interesting to have a structural typed static type system for something that's like Clojure. I'm not sure that could be bolted onto Clojure. I mean, I know that's what the core types library tried to do. I'm not an expert on static type systems, so I can't comment too intelligently on that. But it could be that one of the reasons that didn't become more popular is that the language wasn't designed with that in mind. So I'm sure it was difficult to make a sound type system that described whatever Clojure happened to do.
I think it works okay. I think it's just it's not idiomatic, so it's an ecosystem problem actually. Because you've got types in one part of your program, but not in others, and it makes the value proposition a bit less compelling, basically.
Yeah, and the libraries don't have them.
Yeah.
Yeah, I could see that. It was really slow for a while too, I remember.
Yeah.
So that made it difficult. I tried using it for a year or two.
Yeah, very interesting project though, and he's got his PhD, so everyone's happy.
That's what matters.
Yeah, exactly.
So, I think we are 1.5 hours almost.
Yeah.
Awesome. Are there any other topics that you want to touch upon?
I don't know. I mean, what do you like to talk about?
Maybe a quick gist of computationology talk that you gave.
Oh, okay.
What is it about?
Yeah, so that talk was an excuse for me to describe one of my favorite things from computer science that I feel like is fairly unknown among programmers, largely because it's entirely useless, as far as I can tell. But I've got there's this part of me that's really fascinated with the set theory, infinite sets, that sort of thing, different sizes of infinity. I ran into that 10 years ago, and it was probably one of my favorite things ever. So this is a part of computer science that sort of overlaps with that a little bit. And the talk itself, I broke into two parts. So the second half is what I was just describing, or didn't even describe yet. The first half is slightly more familiar, which is computational complexity. So like the talk is framed as what things happen mathematically when you ask the question, what can computers do? And so it's like looking at mathematical structures that come out of that. And so like one direction you can go with it is like, what can you do under certain constraints, like time or space? So that's what computational complexity is about. And there were, that's it's a topic I enjoy. I don't know a whole lot about it the way an actual researcher would. But I think I know more than average about it, like enough to talk about it for a half hour and point out interesting things. So, like I go over, I go into enough detail about what P versus NP means, and then some of the like more stranger associated phenomena. Most of the talks I do are like, I pick some like overly ambitious topic because I really enjoy trying to figure out how to explain complicated things. Like it's one of my favorite activities, and so that's what most of my public speaking is. And I don't know if it is a good idea, or if I succeed. But I think I've done okay a few times. So I've kept trying up till now. So anyhow, first half is computational complexity. And there's a lot of topics like this. Like I did this with quantum computing, where like there's this topic that a lot of programmers know some surface amount about. Like quantum computing is a topic that you'll see a lot of summaries about, and just like hand wavy stuff that's not really like, it avoids all of the mathematical details. And is probably misleading because of that. And so I like taking topics like that people know a little bit about, and then trying to go deeper in an hour than anybody else would normally try to, by like just trying to think of clever ways to explain things quickly or illustrate them visually, something like that. So that's part of what I did with computational complexity was, like people know that P versus NP means, some soundbitey thing. So I tried to explain it in much more like detail and in a way where you can actually understand what the implications are and that sort of thing. But anyhow, the second half of the talk is about a topic that I don't know if there's a good official name for it. I think sometimes it's called recursion theory or theory of computation, or it's basically if you take the topic of the halting problem and then you just like run after that and see what else you can figure out that has very little implication for programming. So the main idea is about the concept of an oracle, which comes up in computational complexity also. But it's like what could you do with a computer if you had a magical oracle that could solve a particular kind of problem for you? So like the most straightforward thing you can do with respect to the halting problem is say, well, the halting problem is not solvable by normal computers, but if we had a magic oracle that knew the solution to the halting problem for every input, and then we like stapled that to a computer so it could use it as a library or something like that, then what kind of computers would we have, and what would they be able to do? They'd be able to solve the halting problem kind of trivially, and they'd be able to do lots of related things. But then there'd be another halting problem about those computers. So we have like these fantasy computers that can solve the halting problem, and you can run programs on them that may or may not halt. And so we've got this like fantasy halting problem, and those computers cannot solve the fantasy halting problem. It's unsolvable.
So you need next level.
Yeah, so now you can posit that you have an oracle for the fantasy halting problem, and now you have these even more powerful computers that can solve even more impossible problems. And obviously you can take this as many steps as you want. And you can go further than that. Like it gets really bizarre. So that's what that talk is about.
Nice.
All of the like weird things that come up when you do that.
It's basically a talk about religion.
There is a video of it.
Yeah, sure. The religion of numbers.
Okay, I think maybe you need to come back again to explain all the quantum computing and and computationology for us again.
Okay. That would be fun.
For now, I think
He's already came back.
We got to the meat of the. Yeah, exactly. We're gonna continue on the next episode. Once we get dig deeper into 71, and then
CoinDB.
I think that requires its own episode. Like the whole library, and makes sense.
I think that's valid.
Yeah. So thanks a lot, Gary. Thanks for taking the time, and thanks for the test check, of course. Bringing this kind of testing to Clojure, and hopefully you will find more time to build the things that are going to make money for the business, using Clojure or otherwise.
Yeah. Right.
Whatever that is.
Thank you very much. I had a great time.
Thank you. And Ray, any
thanks, Gary.
last words for this episode?
Thank you, Gary. Yeah, it was really good, very interesting, and I'm a big fan of the CoinDB. So let's keep it going.
Well, it's good to hear.
So all we need to do now is write migration scripts from every other database to CoinDB, and then we're ready.
Yeah.
I'll let CoinDB on cloud.
I'll accept pull requests along those lines.
Awesome.
All right.
So I think this is the episode number 52, and maybe a quick logistical announcement. I think we'll be there at not I think, but we will be there. Ray and I, and probably Wouter as well, at Heart of Clojure, August 2nd and 3rd in Leuven. So hopefully, if this episode is out before that event, so stop by and say hi. We're also on Patreon.
That's a Clojure conference I can cycle to.
Yeah, so it's super close, and I think that gives away like it's in the middle of nowhere, but hey, it's Belgium, so Belgium, man, Belgium, as the guide would say. Of course, we're also on Patreon, so check us out, and I think next time we'll continue this amazing Clojure podcast journey into episode number 53 soon. And thanks again, Gary, for taking the time on Sunday, and hopefully we'll meet in real life at some point.
Great, thank you.
Goodbye.
Cheers, Gary.
Bye.
Lemmy from Motorhead. The Ace of Spades!